All right, let's go.
Number 7. Galileo's telescope. It destroyed the center of the universe. In May 1609, Galileo Galilei heard about a Dutch invention, a tube with lenses that made distant objects appear closer. He built his own version within days. By January 1610, he had pointed it at the night sky and changed everything. His telescope was laughably primitive by modern standards. A tube roughly 45 centimeters long, a magnification of about 20 times. The lenses were imperfect, blurry at the edges, distorted by chromatic aberration. A modern pair of binoculars from a department store outperforms it in every measurable way. And yet, in January 1610, Galileo pointed this tube at Jupiter and saw 4 small points of light arranged in a line beside the planet. He watched them over several nights. They moved. Not randomly, they orbited Jupiter. That single observation destroyed 1,400 years of cosmological certainty. The Ptolemaic model, the dominant picture of the universe since the 2nd century AD, placed Earth at the absolute center of everything. Every celestial body orbited Earth. That was not just an astronomical claim, it was theological, political, and philosophical bedrock. The entire medieval worldview rested on it. 4 tiny moons orbiting Jupiter proved that not everything in the universe orbited Earth. Something orbited something else. The center was not Earth. Galileo also observed the phases of Venus, showing Venus orbited the Sun, not Earth. He observed mountains on the moon, proving celestial bodies were not perfect crystalline spheres, as Aristotle claimed. He observed sunspots, proving the sun itself was not perfect and unchanging. Every observation from the same primitive tube, every observation a hammer blow to a 1,400-year-old picture of reality. The church put him under house arrest for the last decade of his life. That is how much his telescope mattered.
Number 6. Newton's reflecting telescope. It solved a problem nobody else could. By the mid-17th century, astronomers were frustrated. Galileo's design, a refracting telescope using glass lenses, had a fundamental flaw. The edges of lenses act like prisms. White starlight entering the telescope gets split into its component colors. The result is colored halos around every bright object, chromatic aberration, blurring, distortion. The bigger you made the telescope to increase magnification, the worse it got. Newton understood why. The problem was the lens itself. You could not fix it by grinding a better lens. The physics of refraction made chromatic aberration inevitable with glass. His solution was radical. Remove the lens entirely. Use a mirror instead. Mirrors reflect all wavelengths of light at the same angle. No splitting, no chromatic aberration. A curved mirror could focus light to a point just as a lens could, without the color problem. In 1668, Newton built the first working reflecting telescope. It was tiny, barely 15 centimeters long with a 2.5 centimeter mirror, but it outperformed refractors 6 times its length because there was no chromatic aberration. He presented it to the Royal Society in 1671, and it caused a sensation. Here is why this matters beyond the immediate optics improvement. Newton's design was not just a better telescope, it was the template for every major telescope built since. The Hooker 100-inch, the Hale 400-inch, the Keck telescopes, Hubble, James Webb. Every single one of them is a direct descendant of Newton's 15-centimeter tube from 1668. A 15-centimeter mirror, the ancestor of a 6.5-meter gold-plated space observatory that can see galaxies forming 200 million years after the Big Bang.
Number 5. The Leviathan of Parsonstown. It found that the universe was bigger than the universe. In 1845, William Parsons, the 3rd Earl of Ross, completed the largest telescope in the world. Built on his estate in Ireland, a reflecting telescope with a mirror 1.8 meters across and a tube 16 meters long, it took hundreds of workers years to build. It was so enormous it could only swing a few degrees either side of the meridian. Observers had to wait for the Earth's rotation to bring targets into view. It was called the Leviathan, and it immediately found something that should not have been there. At the time, astronomers had cataloged dozens of fuzzy patches in the sky called nebulae, clouds of gas and dust within the Milky Way. That was the assumption. Everything in the sky was part of the Milky Way. The Milky Way was the universe, a single galaxy of stars in an otherwise empty void. Parsons pointed the Leviathan at the object cataloged as M51, the Whirlpool Nebula. And through the enormous mirror, he could see structure that smaller telescopes could not resolve. It was not a formless cloud. It had spiral arms, a defined center, a companion object connected by a bridge of material. It looked exactly like what we now know it to be, a galaxy, 23 million light-years away, a system of hundreds of billions of stars entirely separate from the Milky Way. Parsons could not fully interpret what he was seeing. The technology to confirm the nature of spiral nebulae would not arrive until the 1920s, but the Leviathan's resolving power revealed the spiral structure for the first time, planting a question that would take 80 years to fully answer. The question was this: are those spirals nearby clouds in our galaxy, or are they entire island universes, each one as large as the Milky Way, separated from us by unimaginable distances? The answer would rewrite the size of the universe by a factor of billions. Number 4. The Hooker 100-inch telescope. It proved the universe has no edge we can reach. When the Hooker 100-inch telescope at Mount Wilson Observatory in California saw first light in 1917, it was the largest telescope in the world, a 100-inch mirror weighing 4.5 tons. At the time, it was an almost incomprehensible engineering achievement. The mirror alone took years to cast and grind. And in 1923, Edwin Hubble pointed it at the Andromeda Nebula, the fuzzy patch in the constellation Andromeda visible to the naked eye on a dark night, and found a Cepheid variable star. Cepheid variables pulse at a rate directly related to their true luminosity. Measure the pulse rate and you know how bright the star actually is. Compare that to how bright it appears and you can calculate the distance. Hubble measured the Cepheid in Andromeda. The distance came back as roughly 900,000 light-years, later refined to 2.5 million light-years. Either way, catastrophically far outside the Milky Way. Andromeda was not a nebula inside our galaxy. It was an entirely separate galaxy, an island universe containing hundreds of billions of stars. The Milky Way was not the universe. It was one galaxy among many. Then, Hubble and Milton Humason measured the distances and velocities of dozens more galaxies. Every single one was moving away from us, and the further away a galaxy was, the faster it was receding. The universe was not static, it was expanding. In one observatory on one mountain in California, humanity discovered that the universe contained billions of galaxies and that the entire thing was expanding from a single starting point. The Big Bang model was born. The size of the universe expanded from a single galaxy to something containing at least 2 trillion galaxies. The Hooker telescope did not just change astronomy, it changed the question of what the universe is. Number 3. Arecibo Observatory. It listened for what else might be out there. When the Arecibo Observatory in Puerto Rico opened in 1963, it was the largest radio telescope in the world. A 305-meter dish built into a natural limestone sinkhole. So large it could not move. The Earth's rotation had to sweep the sky overhead. Arecibo did not look at the universe in visible light. It listened. Radio waves, the part of the electromagnetic spectrum that travels through gas clouds, dust, and the interstellar medium with almost no absorption. The part of the spectrum where the universe is loudest. What Arecibo found reshaped our understanding of what exists. In 1974, Russell Hulse and Joseph Taylor used Arecibo to discover the first binary pulsar, 2 neutron stars orbiting each other. Over years of observation, the orbital period of this system was found to be decreasing at exactly the rate Einstein's general relativity predicted it should if the system was losing energy to gravitational waves. The first indirect confirmation that gravitational waves exist. Hulse and Chandler won the Nobel Prize in 1993. Arecibo also conducted the most serious scientific search for extraterrestrial intelligence ever undertaken. The SETI program used Arecibo's sensitivity to scan star systems for artificial radio signals, narrowband signals that natural processes cannot produce. In 1974, Arecibo itself transmitted a message toward the globular cluster M13, 25,000 light-years away. The Arecibo message, 1,679 bits of binary data encoding information about humanity, mathematics, chemistry, and our location. It will arrive in 25,000 years, if anyone is listening. Arecibo also bounced radar signals off Venus, Mercury, and the moons of Jupiter, mapping their surfaces. It detected prebiotic molecules in distant star-forming regions. It discovered the first exoplanet system in 1992, planets orbiting a pulsar. The Arecibo dish collapsed in December 2020, an irreplaceable instrument lost. But its 57 years of data are still being analyzed, and the question it spent its life asking, are we alone, remains the most important unanswered question in science.
Number 2, the Hubble Space Telescope. It showed us the universe has a face. Every telescope before Hubble had the same enemy, the atmosphere. Earth's atmosphere blurs starlight. It absorbs certain wavelengths. It shimmers and dances, producing the twinkling that looks romantic from the ground and is a nightmare for astronomers. The best ground-based telescope on the best night in the best location on Earth is still looking through kilometers of turbulent, moving air. The Hubble Space Telescope, launched in April 1990, sits 547 kilometers above the atmosphere. Nothing between its mirror and the universe, just space. The first images were blurry. A flaw in the primary mirror ground the wrong shape by 2.2 micrometers, produced spherical aberration. A billion-dollar telescope that could not focus properly. A national embarrassment. In 1993, space shuttle astronauts installed corrective optics during a spacewalk. Hubble immediately became the most powerful optical telescope in history. What followed was a 35-year revolution in astronomy. The Hubble Deep Field, a 10-day exposure of a tiny patch of sky that appeared completely empty to ground-based telescopes, revealed approximately 3,000 galaxies. In a patch of sky smaller than a grain of sand held at arm's length, every point of light a galaxy, billions of stars each, stretching back billions of years. The universe was not sparsely populated, it was packed, unimaginably packed with structure and light and complexity in every direction. Hubble measured the expansion rate of the universe, the Hubble constant, with a precision that was previously impossible. It confirmed the universe is 13.8 billion years old. It revealed that the expansion of the universe is accelerating, driven by a mysterious dark energy that makes up 68% of everything. It observed the atmospheres of exoplanets. It watched a comet slam into Jupiter in 1994. It imaged the birth of stars inside pillars of gas and dust, the pillars of creation, one of the most reproduced scientific images in history. Hubble did not just improve our view of the universe, it gave the universe a face, made it visual, made it real in a way equations and radio signals never could. As of 2026, Hubble is still operational, 36 years after launch, though operating on reduced capacity with gyroscope issues limiting its pointing ability. It remains one of the most scientifically productive instruments ever built. Number 1, the James Webb Space Telescope. It found that the early universe was already old. James Webb launched on Christmas Day 2021. A 6.5-meter gold-plated beryllium mirror, larger than Hubble's 2.4-meter.
positioned 1.5 million kilometers from Earth at the L2 Lagrange point, 4 times further than the Moon. Protected from the sun's heat by a 5-layer sunshield the size of a tennis court. It observes in infrared, wavelengths of light invisible to the human eye, but essential for seeing the most distant objects in the universe. The expansion of the universe stretches the light from distant galaxies, shifting it out of visible wavelengths and into infrared. To see the early universe, you need an infrared telescope. Hubble could not do this at the required sensitivity. Webb could. The first full-color images released in July 2022 stopped the scientific world. Webb imaged galaxies from 13.3 billion years ago, just 700 million years after the Big Bang. In those images, the galaxies were not the primitive, small, chaotic structures the models predicted. They were large, structured, already forming stars at rates comparable to mature galaxies billions of years older. The standard model of galaxy formation said large, well-formed galaxies should not exist that early. There was not enough time for them to grow. Webb found them immediately, in the first weeks of operation. As of 2026, Webb has continued to produce results that challenge existing models. Galaxies too massive, too soon. Star formation rates too high, too soon. The cosmic dawn, the period when the first stars switched on, appears to have been more complex and more vigorous than anyone predicted. Webb has also detected carbon dioxide in the atmosphere of an exoplanet for the first time. It has observed the atmospheres of TRAPPIST system planets. It has imaged the deepest infrared view of the universe ever captured, revealing galaxies so distant their light left before Earth existed. Every telescope on this list found something that destroyed the previous picture of the universe. Webb is doing it right now, actively, with new data arriving every week. The picture it is replacing is the one Hubble built. The instrument that rewrote everything is now being rewritten by the instrument that came next. That is how science works. Every answer opens a door to a room full of harder questions, and we keep building bigger telescopes to ask them. 7 telescopes, 4 centuries, 1 continuous project, understanding what the universe actually is. From a tube that proved Earth was not the center, to a gold-plated observatory finding galaxies that should not exist. From a 15-centimeter mirror that solved chromatic aberration, to a 6.5-meter mirror rewriting the history of the cosmos. We went from seeing 4 moons of Jupiter to detecting carbon dioxide in the atmosphere of a planet orbiting another star in 400 years. Subscribe to Cosmic Hives. See you in the next one.